Hello, I'm Channa Bankapur. I'm going to discuss my solution to the lead code problem, minimum cost to move chips to the same position. It's today's problem in the November lead coding challenge. And the problem definition is we have n chips here, and each of them are at some different positions. They are given, and we need to move all the chips to the same position. So we have two kinds of operations here. Either we can move a chip to the left or to the right by two positions, and that costs nothing. And another one is we can move a chip to the left or to the right by one position, and that costs 1 unit. So we need to find the minimum cost needed to move all the chips to the same position. All right. So it's a relatively easy problem. Actually, it's very easy problem. And so let's take an example here to understand. So in this case, there are three chips at position numbered 1, 2, and 3, and we can move chip at position 3 to position 1. That is going to cost 0 actually. And then we have two chips at position 1 and one chip at position 2. The one at position 2 can be moved to position 1, and that's how the overall thing costs 1, right? So it's a very simple example. Suppose there were little more than that. Suppose there were, say, two chips here, or maybe three chips here, and then two chips here. In that case, I can still move three chips from position 3 to position 1. So we're going to have 4 here, and this still costs nothing. And there are two chips at position 2, and moving them to position 1 is going to cost you 2. So this will cost you 2 in this case instead of 1, right? Um, so what if there are, say, at position number 100, there are a bunch of them. Suppose there are, say, some, 4, 5 of them, right? So, but we can move all of these at position 100 to position 2 in zero cost actually, right? It doesn't cost you anything. So in other words, we can move all the chips at odd positions to position number 1 because that costs nothing, and then all the chips at even position to position number 2 because and that costs nothing. So now when they're at position number 1 and 2, whichever is minimum, whichever has the less number of chips, we move to the other one. In this case, 4 is lesser than 7, so I'm going to move 4 here, and that's going to cost us 4, right? So that is the approach I'm going to use. I'll figure out the number of chips in odd positions and number of chips in even positions separately, and whichever is minimum is going to be the cost, so that they are going to move to other one. All right. So that's the approach, which is very simple and it should be fast. Let me show you my code. Um, So here I'm counting for each chip here. I'm counting whether it's in odd position or even position by this, with the bitwise and with 1. That's going to just see whether the least significant bit is 1 or 0. That tells us whether it is odd or even. So accordingly, I'm going to increment the even position counter or odd position counter. So finally, whichever counter has lesser number is going to be the cost, right? And that's how it's going to work. All right. So let me submit the code and see. So it accepts, and the time complexity of this one is linear because there is only one for loop where I'm going over all the chips here, and so this is linear to the number of chips we have. All right, so it's an easy problem. Okay, so if you like the video, please subscribe to the channel, and happy coding. Thanks for watching.